Okay. So I'll be doing example 1.3 from CMOS VLSI design, a circuits and systems perspective. This is in section 1.5. The question asks to draw the stick diagram for a CMOS gate computing Y is equal to A plus B plus C D bar. So first, the course of action will start from the formula and we'll go to the CMOS logic into the stick diagram. Once you have the CMOS logic, it's very easy to derive the stick diagram. So CMOS diagram is composed of an NMOS and PMOS part. NMOS is the pull down network and the PMOS is the pull up network. To draw the NMOS, we'll start with just the Boolean equation without the bar. Remember that the OR symbol is parallel and the dot is series. And you can remember this by A or B or C or D means that you can take either of them. You have a choice. And so in order to have a choice, you have to have them in parallel. If it's A and B and C and D, it means that you have to go through all of them. Thus, you have to use series. So we can first write the A and B part, B and C. And as you can see, they have an ORing among them. So you have to OR them, or you have to put them in parallel. And then all of this is in series with D. And all of this is connected to ground. So this is your NMOS, your pull down network. To make your pull up network, you simply have to invert this NMOS or this pull down network. An easy way to derive this, you could also take the Boolean logic and add the negation. So this will turn into A plus B plus C bar or D, A and B and C or D bar. And if we remember, OR is parallel, dot is series, and so we'll have two rails, one for PMOS, and then one for D, and the others for A, B, C series. And don't forget to have the dot to denote the PMOS. There you have it. All of this is connected to VDD, and then this is connected to the output, Y. This is connected to the output. And the final thing is to simply combine the pull up and pull down network. My will work. There we go. Hey, what's going on? Pull up and pull down network. And that will give you the CMOS logic. Now, next we're going to label the source and drain, which will help us later when we try and generate the stick diagram. So source, each transistor has one side is source and one side is drain. The source will always be closest to your source, which is ground and VDD. So for your pull down network, these will be the source because they're the closest, and the other side must be ground or drain. So this will be source, drain. And for here, since VDD is up, or our source is up, we have to connect it like this. Made a little mistake here. Small fix. There we go. Now that we have our CMOS logic, we can make our diagram. So in every stick diagram, make sure you have first the two lines, which will be your VDD and your ground. Next, you'll have your P diffusion and your N diffusion. And diffusion. Next, you need our polysilicon layers, and the number of them is determined by how many terms we have. So because we have 4, we can put 4, or we should put 4, as so. And each junction of diffusion layer and polysilicon is a transistor. So in this diagram, we have 8 transistors. And as you can see, we have 1, 2, 3, 4, 5, 6, 7, 8 transistors. Okay, so let's label these A, B, C, and D. Now you can reorder them however you like, but I'm going to stick with these labels for now. So I like to start at the very top where source VDD is. As you can see, A source and D source is connected to VDD. So I would have a source here and a source here, and then I'd connect them like this. You don't want to have, say, the source here, because whatever you put as source or drain on B and you connect it here, it wouldn't make sense, because as you can see here, B source, oh, I made a mistake. B's source drain, there we go. B's source, neither source nor drain is connected to VDD. So you cannot do that. Drain. And the same logic works for C. So you have to do it like that. Then you can, for every source, the other side has to be drain. Okay, then that completes that. Let's go to the output. As we can see, C's drain and D's drain are connected to the output Y. So if we put D here, we'd have to put D here, because D cannot be here, since whatever B, if B is source or drain, having a connection would be inappropriate because, as mentioned before, source and drain was not connected to VDD, nor is it connected to the output Y. So you cannot do that. And this will allow a connection to Y. Now this will be source. And as we can see in the diagram, A's drain and B's source are connected. So we have to make sure that they're connected right here. And as we can also see that B's drain and C's source are also connected. So we can put this here. And that makes these combinations work. Moving on to the pull down network. As we can see, D's drain is connected to the output. So let's isolate this D and connect it here. Now we have to make sure that the source, we have to make sure that the source of D is connected with A's drain, B's drain, and C's drain. To do that, this will be source. So for convenience, let's put here C's drain, C's drain, and let's put this here and here. What this allows us to do is make one wire connection that satisfies whatever we have in the CMOS logic. A's drain, B's drain are connected with C's drain and D's source. Since these are drains, we can put these as sources. Finally, we just have to connect them to their source ground. So A is connected, A source is connected to ground, and oops, we can kill two birds with one stone with one wire connection. Since B's source, C source is connected here. And that should be the stick diagram.